Important derivatives of anthracene. First, anthraquinone is also known as 9,10-anthraquinone. Three quinones of anthracenes are known. They are 1,2, 1,4, 9,10 anthraquinones. 9,10-anthraquinone is of considerable industrial importance and is usually referred to simply as anthraquinone. Preparation first from anthracene. When anthracene is oxidized with sodium dichromate and sulfuric acid or air in the presence of vanadium pentaoxide, at about 400 degrees centigrade temperature, anthraquinone is formed. Next, from benzene and phthalic acid, phthalic anhydride is treated with benzene in the presence of aluminum chloride. In this reaction, first of all, orthobenzyl benzoic acid is formed. Treatment of this with considered sulfuric acid yields anthraquinone. Next, properties, physical properties. It is a pale yellow solid. Melting point of the compound is 26 degrees centigrade. It is insoluble in water but it dissolves in boiling benzene. Next, chemical properties. Anthraquinone shows very little resemblance to parabenzoquinone. Example, it has no smell, is not volatile, and is resistant to oxidizing agents. It is probably because the carbonyl double bonds are each part of an aromatic system. It behaves more like an unreactive aromatic benzene. Some of the important chemical properties of anthraquinones are described below. First, reduction. Anthraquinone undergoes reduction with alkaline sodium hydrosulfide Na2S2O4 or zinc and alkali NaOH to form 9,10-anthraquinone. This dissolves in alkali to yields a disodium salt of 9,10-dihydroxyanthracene, which is a blood red in color. Its formation may be used as a test for anthraquinone. When the red solution is exposed to air and shaken, anthraquinone crystallizes out. Next, nitration. Anthraquinone undergoes nitration with concentrated nitric acid in the presence of sulfuric acid to form 1-nitroanthraquinone. When 1-nitroanthraquinone is heated with ammonia, by heating 1-aminoanthraquinone is formed. Some of the important chemical properties of anthraquinone are described below. First, reduction. Anthraquinone undergoes reduction with alkaline sodium hydrosulfide Na2SO4 or zinc and alkali to form 9,10-dihydroxyanthracene. This dissolve in alkali to yield a sodium salt of 9,10-dihydroanthracene, which is blood red in color. Its formation may be used as a test for anthraquinone. When the red solution is exposed to air and shaken, anthraquinone crystallizes out. Next, nitration. Anthraquinone undergoes nitration with concentrated nitric acid in the presence of sulfuric acid to form 1-nitroanthraquinone. When 1-nitroanthraquinone is heated with ammonia, 1-aminoanthraquinone is formed. Next, sulfonation. Anthraquinone undergoes sulfonation with fuming sulfuric acid at 160 degrees centigrade temperature to give 2-anthraquinone sulfonic acid. Uses. Anthraquinone is used in the manufacturing of alizarin and several other dyes. Next, alizarin. It is also known as 1,2-dihydroxyanthraquinone. It is 1,2-dihydroxyanthraquinone. Alizarin derives its name from the fact that it was first obtained from the root of the madder plant. It is an orange or red crystalline compound. Its molecular formula is C14H8O4, which formerly prepared from madder and now made synthetically also. Preparation. Anthracene undergoes oxidation to gives anthraquinone, which react with bromine to form an intermediate, which when uh, when react with potassium hydroxide, it will ultimately form alizarin. Next, structure of alizarin. The structure of alizarin, first elemental analysis and molecular weight determination shows that the molecular formula of alizarin C14H8O4. Reduction of alizarin with zinc dust at 400 degrees centigrade temperature produces anthracene. This indicates that it has the same carbon skeleton as that of anthracene. Anthracene reacts with acetic anhydride to form a diacetate. This indicates the presence of two hydroxyl group in the molecule. Alizarin can be prepared by condensing phthalic anhydride and catechol in the presence of sulfuric acid at 180 degrees centigrade temperature. This shows that alizarin is a dihydroxy derivative of anthraquinone, and both hydroxyl groups are substituted in the same benzene ring. Same in the reaction, phthalic anhydride when react with catechol in presence of sulfuric acid by heating, it will gives alizarin, which is also known as 1,2-dihydroxyanthraquinone, in which both hydroxyl group are substituted on same ring at first and second positions. The above fact limits our choices to two structural formulas for alizarin, A and B. Alizarin on nitration yields two isomeric mononitro derivative, both of which on oxidation gives phthalic acid. This shows that in each of these derivatives the NO group is substituted on the hydroxylated benzene ring. Uses alizarin is most commonly used for the derivatization of other dyes, but it is also known as textile dyes, pigments, and as an indicator